Yeah, so let me give you a quick revision of the dot product again, right? And then we'll start. So I did the revision in Amna's and Elham extra class. So and Rishida, so how's the preparation going?
Sir, I think it's going well, sir. I'm sorry I didn't attend. I had little time for it preparing for the
Yeah, yeah,
exams.
yeah, 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 yeah. So that's totally all right. That's totally all right. So you are preparing, right? And whenever you have any problem, right? Any doubt in your preparation, so please let me know. Okay.
Yes, sir.
Yeah, so no, don't think about that you didn't join it because you had your reasons, right? So, and those were valid. So don't think about that. Okay, so yeah, let me quickly recap what we did in the scalar product. So we had two vectors, right? And then the angle between them was given, right? So we calculated or we defined the dot product as so A dot B was AB cos theta, right? So these are two vectors, and when they multiply together, they give a scalar. So this was the idea of the scalar product, right? And this scalar product is used in calculating the. So this is used in calculating the angle between vectors, and this is also used to calculate work done, power, right, and etc etc. So right, so these are the things. So this is the use of the work done, and we can also calculate the projection. So this is also used to calculate the projection of vectors, right? So, and then we define the two vectors in the Cartesian form. So we defined the two vectors axi plus ayj and azk. So this is in three dimension, right? And this is the Cartesian form. So in Cartesian form, I, j, k are the unit vectors in x direction, y direction, z direction. So from there we calculate the magnitude of this vector as this one, right? And we have another vector which is px I b y j b z k. And when we calculate the dot product, we get ax bx, the x components multiplied together, y component multiplied together, and z component multiplied together. So this is the dot product in the Cartesian form, right?
Yes,
And
sir.
after that, we learned about the projection. So let's say we have a vector. So this is the theta angle between the vector. This is A vector and this is B vector. So when I drop down this V vector along A, right? And we know that A vector has two components, two parts, magnitude and direction. So direction of A is A hat, right? So what I do is that I break this B vector in two components and I drop down this B vector in this path. So this is what? B cos theta, right? So this B cos theta is the component of B along A direction, right? So this b cos
Sir, can
theta,
you again?
yeah. So what you have is that, okay. So you have two vectors. Oh, this is, so I have to print myself. Okay. So you have two vectors, right? So
Yes, sir.
this is b vector and this is a vector. And what you do is that you have this a vector, right? So this has two components. This one, right? And then this one. So one is the horizontal component and the vertical component, right? So
Yes, sir.
this horizontal component is along this b vector, right?
Yes, sir.
So when you drop this, when you take the horizontal component of this A vector, so that would be called the projection of A vector along this is the B vector. Understood?
Yes, sir.
So what is this component? The horizontal component?
B cos theta.
Okay, so you are
A cos theta.
A cos theta, right? So that is what we call the projection. Understood?
Yes, sir.
Oh, did I draw? Okay, so if I'm taking this B, so projection of B along A would be how much?
B cos theta.
B cos theta, right? Good, good. So this would be, this is A vector and I'm taking the projection. So this is B cos theta. Okay. So if I write component or if I write projection of B along A. So that is B cos theta, right? So component would be B cos theta, and if I'm writing projection vector, so this projection vector would be projection vector. This would be B cos theta, and what is the direction? What is the direction of this vector?
A.
A
A
hat,
cap.
A hat, right? A cap, absolutely right. So this is the projection vector of B along A. And if I ask you that component or projection of A along B. So that would be, let's say, I draw this diagram in this way. So I drop down this A part in this direction. So that is A cos theta, right?
Yes, sir.
So this is A cos theta, right? And if I write the vector, projection vector, so this will have certainly a direction. So this would be A cos theta. And what would be the direction, guys?
B cap.
B cap, right? Good. So this was about the dot products that we need to do. Okay. And now, if I ask you guys that what is, let's say A is AX, I, AY, J, and then AZK. So what would be A dot A? Can you guys tell me? What would be A dot A?
A x plus A
Yeah, so AX into AX, right?
into AX plus AY square.
Oh, so AY square, right? So AY into AY square, and then AZ square.
B A Z square.
So this is AX square plus AY square plus AZ square. So what is this? This is actually A square, right? Because magnitude of A is how much?
Root of AX square plus AY square plus AZ square.
Right? So then if I square this, so I'll get this one. Understood, everyone? So if I multiply, if I take the dot product with itself, I get S square. So up to this point, do you guys have any doubts? Yes, guys.
No, sir.
Ilham and Amna, this we already did, right?
Yes,
So,
sir.
right. So now let us start the next chapter, which is work, work, energy, and power. Right. So generally in our daily life, right? If let's say if some laborer is right is picking up some bricks, right? And he is moving some bricks. Or let's say if some painter is painting, let's say some portrait. Or let's say if you are reading some textbooks, right? Or if you are making a note. So we generally say that you are doing a work, right?
Yes, sir.
We generally say that you are working. If you are studying, and then we say that you are working, right? If somebody is going to the office, then we say that he is working. So we have different definitions of work, right? Similarly, there is some we have different definitions for energy, and we have different definitions of power. So we say whenever some bodybuilder comes, so we say that he is more powerful, right? So we have certain definitions in daily life, but those definitions slightly differ from the physics point of view. So in physics, these work, energy, and power, these have separate definitions, right? So they have some peculiar definition. So if you say that from physics point of view, right? If you are saying that somebody is doing some work, so in that context, it has some specific meaning. Understood, everyone?
Yes, sir.
Yeah. So in this chapter, we will understand about what is the physical definition of doing some work, or what is energy, or what is power, right? So let's understand about what. And in the previous chapter, what did we learn? So what physical quantity did we learn in the previous chapter? Yeah, in the
So many physical quantities.
yes,
Many physical quantities.
many, but all those physical quantities have some same concept, right? So all those were connected with some same concept. We yeah, in the previous chapter we defined what? Yes, Elam,
Um,
Amna. Yes, Ishita.
sir, is it force the
Yes,
physical quantity?
yeah, absolutely right. Force, right? We understood about the force, right? So how it comes into existence, what is the meaning of the force, right? So we talked about some different forces, right? So in
Yes.
the yeah, so in the previous chapter we talked about the initiation or how this course existed, right? Now from this chapter onwards, we will study about the application of the forces, right? So what they actually, what those forces do, right? So let's say that so the definition of work comes from that force only. So let's say that you have an object, right? You have an object and you apply some force in this angle. So this is some angle and you apply some force. So this is some force, right? So let's say that this object moved to this point. So it moved to this point and it reached here. and let's say the displacement was okay. This has some mass and this has some. Understood, everyone?
Yes.
So the force is, yeah, the work is defined like this. So work, it is defined as the product of the component of force along the displacement and the displacement of the object. Right? So this is the physical definition of the work. So you have a force, right? And it moved this object to this point, so it gained or it gained some or it did some displacement, right? So the work done is defined as the product of the component of force along the displacement. So what is the component of force along the displacement? This is F. So what is the component of force along displacement?
F cos theta.
F
ठीक है?
cos, yeah, F cos theta, F cos. So we are talking about component, right? So we are talking
Yes.
about component, so we don't write a direction. Good, good. So F cos theta. Understood, everyone?
Yes, sir.
Amna, what about you? Yes, Amna.
Yes, sir.
So component of force along displacement. This is F cos theta multiplied by the displacement itself. Understood, everyone? So this
Yes.
is F d cos theta. So what is this F d cos theta? How do we write this F d cos theta? Yes. How do you write this F d? What is the meaning of F d cos theta? Have you seen these kind of terms somewhere? F d cos theta like terms somewhere that you studied? Yes, guys. Yes, everyone. So have you guys seen this F d cos theta somewhere?
Sir.
Yeah. So where did you see where did you see this part? These terms? So scalar product. We just talked about this. What is a scalar product? Let's say you have A and B. So what is scalar product?
It's a dot product.
Yeah, scalar product, and we can also say that it is also defined like dot product. Why we are calling it scalar product? Because we get a scalar quantity. So we
Okay,
can
sir.
also, yeah, so we can write as a dot product or scalar product. Right, so scalar product or dot product. Okay, so yeah, so AB cos theta, this is the dot or scalar product, right?
Yes. Yes, sir.
So this is written as A dot B, right? So I can write this as
F
F,
dot D.
absolutely right. So this is how you define the what from the physics point of view. So if painter is painting something, then from physics point of view, he is not doing any work. right? So, is this part is the definition of work clear to everyone?
Yes, sir.
So you see that this work is dependent upon how many quantities?
Two quantities.
So one, two, and this angle is also important, right, Ishita?
Three quantities.
So it is dependent upon three quantities. So
So there's also this equation which is weight equals to F by M, like,
F by
or
M,
F or F force into mass.
force into mass.
I don't know. I think it was that.
F by M is acceleration. F is ma, so acceleration is F by M, right? Weight is mg. So unfortunately, weight and work have different signs. So this may be confusing, but this is weight and this is work,
Oh, oh, sorry, sir.
right? So unfortunately, we have only 26 letters. So yeah, so this is how we represent work, right? But not this is weight, right? This is a force due to gravity. So
Yes.
okay, so we see that this work is dependent upon three quantities, right? So if uh, f is zero, if f is zero, then the work done would be zero, right? Of course, if there is no force acting on an object, then of course the work done would be zero, right? And second thing, we can say that if displacement is zero, right? You are applying some force. So let's say that you are applying some force on the wall, right? And the wall is not, so you are not able to move the wall. You are actually applying some force, but you cannot move the wall, right? So that means that you are not doing some work. Understood? So if D is zero, then the work done would be zero. Okay. And also, can you guys tell me that do you have this dot product zero at somewhere? When your dot product is zero?
So,
Yes.
cos.
Yeah. You are right. So
So when A and B are perpendicular.
absolutely right. So if A and B are perpendicular, then cos theta is cos 90. So this is zero. So if F and D are perpendicular, then the work done would be zero, right? And you can see that this work done is a scalar quantity, right? And before I talk about the physical quantity work, so let us also talk about that uh, whether this work done can be negative or not. Yeah,
Yes, sir, because displacement can be negative.
yes, because this theta can be greater than 90, right? So from 0 to 90, you have this f d cos theta, right? So your theta from 0 to 90, your cos theta is positive. And if you go beyond 90 to 180, then your cos theta is what? Negative, right?
Yes.
So work done can also be negative depending upon the angle between F and D. Okay, so these are the preliminary. Then I will talk about the work done, which is a physical quantity, unit, and something like that. So you guys, please note it down. And if you have any doubt in work done, then you can ask. Whenever you guys need me to scroll down the screen, you guys can tell. Who got disconnected?
Learnivio.
Learnivio. So host has abandoned us, right? So we are on our own. So okay, you guys. Sorry about the joke. You guys, please note it down. And whenever you want me to scroll down the screen, guys, tell.
So can you scroll down?
So
Answer.
done. Everyone.
Yes.
So important thing to note down about work is that it is a scalar point, right? Because it is a dot product and dot product is a scalar quantity. So it is a scalar quantity, right? And its uh, SI unit is joules, right? And we can also write as Newton meter. Okay. And can you guys tell me about the dimension formula of this word? So you guys have not talked about the dimensional formula, but can you guys tell me about the dimensional formula of this word? I have given you the mathematical expression. This is FT. So you guys please calculate the dimensional formula of word. Okay. So you guys know how to calculate the dimensional formula, right? Right, everyone.
Yes, sir. Just a moment.
Okay, so please calculate and tell me. And where is this Akif? Okay, so what I will, and Rishita, when is your exam?
Sir, it starts on 20th.
28th. 20 or 28?
2020.
20, 20th. Okay. So we have 10 days. Oh, so we have
Sir,
started. Yes.
is it ml2 t to the power minus 2?
Okay. So ML2 T to the power minus 2, right? So let's take the answers from Rishita and Amna and then.
So physics is the last exam. It's on 27.
27. Oh, so are you not getting any study leave between the exams, consecutive
So
exams?
it's actually like I only have one weekend between the exams, and that is for biology. No, wait, not biology, chemistry. And after chemistry, I have 1 day leave, and then after that, I have physics. And the 1 day leave is not because of the study leave; it's the profits birthday or
Yeah.
something, and that's why I have a
So
holiday.
why are no? Yeah, why are not they giving us some? Because at least you guys should have 3 days to collect whatever thoughts you have, and so at least you guys need 3 days, right? So to collect all your
Yes, sir.
thoughts and prepare all the subjects. I don't know. So because in 11th and 12th class, you guys need at least 3 days, right? Because in one day we cannot collect whatever we have learned in. So how many chapters are going to come, Vishka?
So the first 4 chapters.
First four. Okay, so we have not done this dimensional analysis. That is easy. That's why I have not. I will take an extra class and complete that one. But that is
No,
not.
yes,
Yeah. So you guys please calculate. What are you getting? Amna and Chita.
sir, I got the same ml square d minus.
ML square T minus 2. Amna, what about you?
Same, sir.
Same, right? So because 4 says what? 4 says MA and then distance. So M is kg, A is meter per second square, and then you have this distance which is meter. So kg is mass, m square, so length square per second square, so per time square, right? Good, good, everyone. So okay, good. So you guys know the dimensional formula for work is it's dimensional formula is ml square t minus 2, right? And this is the same for energy. So energy has this dimension. Okay, if you calculate half mv square, so you will get the same, right? Okay, so this was about the work, right? Let us do some calculations to understand about the work. Okay, so let's say that an object was applied by a force of 20 Newton and it 20 Newton at an angle of at an angle of let's say 30 degrees, right? So let me write it as 60. And it moved 3 meters. Find the work done by the applied force. Right. Please, you guys calculate and tell. So please calculate and tell me guys. And Ilham and Amna, when you so you guys have 27 and 26, right? The exam date
Yes.
is. Okay. You guys also start preparing. And in first four chapters, if you have any doubts, so please ask. So, what was the most difficult chapter in these four chapters? So, for Rishita, it is motion in a plane, right?
Yes, sir.
And Ilham and Amna, what about you guys?
So
So
motion
for
and work energy.
Work energy, we have just started. So,
Yes, so but in school they taught the collision and
oh,
all. I don't
oh,
understand.
okay, okay. So, let's quickly do this chapter, right? Today is 10th, and next week I will talk about this energy, power, and then in the next class I will talk about solutions, hopefully.
so I got 30 joules per 10 M.
30 joules, right?
So how do we oh okay, so 30 joules or Newton meter.
Yeah, we can write a Newton meter also, right?
Yes,
Because
sir.
that is F into D. So F is Newton, right? And this is meter. So we can write joules or meter. Okay, so yeah, Elham and Amna, what are you guys getting?
So 60.
60. Okay, so we have a disagreement here, right?
Sir, 20 joules.
20. So all these three answers are different. So what is work done? That is F D cos theta, right? So F is 20 and this is 3 and then we have this cos 60, right? So 23 and then 1 by 2. So 10, so 30. How did you guys get all these 60 and 20? Yes, did you guys
I
find?
sir, I forgot cos 60.
Yeah, so there is also, this is not correct, right? So, yeah, because this is not 0 degree, right? If
Yes, sir.
theta would have been, yeah. Okay, understood everyone?
Yes, sir.
Yes, sir.
So now the next kind of question would be like that if the uh, if the force is, let's say, 2I plus 3J plus 5K Newton, right? And it displaces and the its displacement if the S is 2I plus 5J and then plus 2K, right? Then find the work done on the object. Okay, so now we have to use the different formula. So please, you guys calculate and tell me the work.
So in displacement it's 2K, right?
2I plus 5J and 2K. Yes. So now we have to use this one. Right, guys? So please calculate and tell. Yes, what are you guys getting?
So in displacement, the value of k hat is 2.
Yeah, yeah, two. This is two.
Okay, sir.
So this is dot product. Why? We have to take the dot product, right, guys? So in dot product, only the x, x, y, y, z, z. That is how we calculate, right?
Sir, I got 29 joules.
29. Okay. Yes, Elham and Amna, what about you guys? Yes.
Sir, I'm getting confused.
Okay, no worries, no worries. So Elham is confused. Amna, what about you? Stuck at some point,
Not getting, sir.
not getting. Okay, so let us try to calculate, guys, right? So we have two vectors, right? We have one vector which is 2I plus 3j plus 5k. And then we have this S vector which is 2I plus 5j and then plus 2k. So now we have to take the dot product, right? So in dot product, we already know that A dot B is, this is AX BX plus AY BY plus AZ BZ. So AX BX, right? Then AY BY and then AZ BZ, right? Everyone, is this clear?
Yes, sir, yes.
So this would be 4, 15, and then 10. So 29. So this would be 29. Okay.
Okay, sir.
Yeah. So you guys please note it down and yeah. So good that you guys didn't keep the question to yourself and yeah. So whenever you have doubt, so please ask. And whenever you guys have noted it down, so please tell. Noted, Elam and Amna.
Yes, sir.
So now you
Yes, sir.
guys, yeah, you can have a different question. So the question would be that a force of, let's say, 2I plus 3j plus 5k is applied on an object and it displaces from, let's say, A, which is 2, 1, 3 to B, which is 5, 3, 4. Right. Then find the work done. Right. So what is given? F is given, and we have to find the displacement vector. So
So A vector is like 2i plus j plus that, like
ab-
that.
absolutely right. Absolutely right. Right. Good. So 2 is F is this, and we have to find the displacement. Displacement is what? AB. Right. AB vector. What is this vector? So as Rishita is saying, A vector we can write as 2i plus j plus 3k. Okay, B vector is 5i plus 3j plus 4k. So we can find out AB, which is A, or we can write this as B minus A vector. Okay, which is 5 minus 2, so 3i plus
So how do we know which one do we take? Like which one do we is if it's b vector minus a vector or a vector minus b vector?
yes, absolutely right. So how do we calculate the? So we know that this is a point which is 2 comma 1 comma 3, and this is b point which is 5 comma 3 comma 4. So if I want to calculate the separation, right? So the separation coordinate would be 5 minus 2, right? Then this would be 3 minus 1, and then this would be 4 minus 3. Is this part clear?
Yes, sir.
Or we can also, I don't want to do right. Okay, so you can write this as x2 minus x1, y3, y2 minus y1, and z2 minus z1. We can understand it like that, or we can understand it in this. So we have this 2 comma uh, 1 comma 3 point, and this is the position vector, right, in this direction, right? And we have this
Yes.
b point which is 5 comma 3 comma 4. This is this vector. So displacement is this, right?
Yes, sir.
So do we know the triangle's law? This is b. What is the triangle's law? Triangle sum. So a plus ab, this would be how much? This one plus this one. What would be this? Triangle's law. Yeah. Okay. So let me just revise this again. So this is, let's say this is A, this is B. So what is this, guys? What is this?
A B. uh,
Right? From the triangle's law. Do you guys remember now? This one plus this one is this one. Forgotten? Yes. Okay. So let's forget this. And you know about parallelogram's law, right? Parallelogram's law,
Yes.
right? So let me write
Yes.
this as A, and let me write this as. So in the parallelograms law, what you do, you take B and put it in here. You take A and put it in here. This is your A, this is your B. So what is this?
A plus B.
Right. So this is your A plus B. This is A, this is B. Right. This is A, this
Yes,
is
sir.
B. So this becomes A plus B. Understood? So this is A, this is B. So this will be clear. Is this
A
clear?
plus B.
Right. So similarly, we are going from here. So this is this, and then this is this. So this plus this would be what? Clear?
Yes, sir.
So A plus AB would be B. So if I calculate AB, so that would be B minus A. So we don't want to complicate things. You guys don't think about this. Just remember, if whenever two coordinates are given and you want to calculate the displacement, so you write it as x2 minus x1 I hat plus y2 minus y1 j hat plus z2 minus z1 k hat. This would be easier to remember, right?
Yes, sir.
Okay, so yeah, then oh, you want to note it down, but this will confuse me. So you can note it down.
Sir, I got force as 17 joules.
17 joules. Okay, so right. What has happened? 'Now it is yeah. So we now know what is Nishita is getting 17 joules. So remember this, guys, that whenever you get two coordinates, right? 2, 1, 3, and B, which is 5, 3, 4, and you're asked to calculate the displacement. So you calculate the displacement by this. Always remember this, right? Note it down somewhere. So you have this vector, right? And then you can calculate the work done, which is F dot AB, right? So this is, as Rishita is saying, 2 into 3 plus 3 into 2 plus 5 into 1. So this is 6 plus 6 plus 5. So 17 joules. Is this clear, guys?
Yes, sir.
Okay, so ultimately we have to calculate the displacement and the force. So this is our. Please note it down, everyone, and then we'll do the, yeah, so then we'll learn about the next topic. And if you guys have any doubt, so Elham and Amna, any doubt in this question, guys?
No, sir.
Okay, so please note it down, everyone, and then yeah, and then I'll talk about it. Yes, whenever you guys have noted it down, please tell.
Done, sir.
Then, Amna, what about you?
Done, sir.
Okay, so when we were studying this work done, so what was this peculiar thing about this force? So we did three kinds of question. So first one was this 20 Newton and this force and this force. So what is the similarity between these three forces? What is the similarity?
Oh,
Any-
20 Newton is scalar, while the second two questions are vector quantities.
No, no. So I'm asking about the similarity between these three vectors, right? So force is always a vector quantity, right? I am talking about magnitude in here. So force is always a vector quantity, right? But in this question, I talked about magnitude, and in these two questions, I wrote the vector representation. But I'm asking about in these three forces, what is the similarity that you guys are finding? Anything which is common? Yes. Okay, so let me write two things. And then you guys would be able to. So let's say you have F, which is 40 Newton. And let's say that yeah, if I write F, which is 3x Newton. So do we have any difference in these two forces? Yes.
Uh, yes, sir.
Yeah. And what is the difference, Rishida?
The variable.
Absolutely. So why are you hesitating? So this is dependent upon x variable, and this is a constant one. So this is a constant, and this is a variable, right? So all these forces in the previous question. So in 20 Newton, this force, right? Is it dependent upon some variable x, y, z?
Yes, sir.
Where is x and y and z,
No, sir. It's not.
right?
So all
So
of them are constants.
so all these three forces are constants, right? Understood, Elham, Amna? Understood? Yes, guys, understood.
Yes, sir.
Okay, so whenever we have, so then work done can be of two types, right? So then depending upon the nature of force. Types of work done. Right, so there are two types. One is work done by constant force for uniform force, right? And this you already learned. So this is F dot S. Okay. And but whenever we have a variable force, so work done by variable force, right? So this will change to integral. So this would be integral of F dot dl. Okay. From let's say this limit from lower limit L1 to L2, right? So is this part clear?
Yes, sir.
What, right? So these are the two kinds of work done that you have. Work done by constant force and work done by variable force. So let's say that I give you a force like this. So question is that a force F, which is let's say minus K by X, is working on an object and it displaces the object from let's say 1 meter to let's say 3 meter, right? So we are in the x direction. Remember, we are applying the force in the x direction only. Okay. So then find the work. So work done would be what? Work done would be integral of f, and this is in x direction, so f dx, right? And what would be the limit of the integral? Integral of x, limit of x. Yes, guys. What is the limit?
dx by dt.
So limit is 1 to 3 meters. So 1 to 3 meters. Understood? So this is the limit of the integral. Limit of the integral. Because this is the position of x, right? From 1 to 3. So whenever you have an integral y dx, so you write the limits of this x, right? So x1 to x2, right, guys? So x1 is
Yes,
1
sir.
and x2 is 3 meters. So this would be the work done. And you guys already know that your f is how much? This is a constant, so minus k by o. Let me write it as x squared. So k by x squared. So you guys please calculate and tell me what would be the work done. You guys already know the integral, right? What have you guys forgotten?
So why did we do x square?
Oh, because yeah, because I
Oh,
know
the
that.
question was x.
Yeah, so I changed the equation because I was getting this 1 by x integral, and I know that this is log x. That is why I changed the equation, right? Okay, so you guys please, you guys remember the integral? Yeah. What is the integral of xn dx? What is this integral? Do you guys remember? Rishita, Ilham, and Amna, do you guys remember? Yes, guys.
Sorry, sir.
Do you guys remember the integral? What is the integration of xn dx? Forgotten. Okay, so this is xn plus 1 divided by n plus 1. So now do you guys remember? Yeah, do you guys remember?
Yes, sir.
Okay, so keeping this in mind, please calculate this integral. Please, you guys do the calculation and tell me. And if you guys are stuck, so you guys know that please first you guys try.
So can you show how to do this?
Okay, so yeah, so good that you guys asked me. Okay, so this is minus k is constant, so we can take it outside. And then this is the integral of 1 to 3, right? And then 1 by x squared dx. So how can we write this? This is 1 to 3 and this is x minus 2. Right, guys?
Yes, sir.
So x minus 2 integration would be how much? This would be x minus 2 plus 1 divided by minus 2 plus 1. Right? So we can write this as minus k and this is minus 2 plus 1 divided by minus 2 plus 1 and from 3 to 1. So we will get minus k and this is x minus 1 divided by this is minus 1 and from 3 to this is 1. So this minus 1 goes outside, right? And this becomes positive. So this becomes 1 by x 3 to 1. Is this clear, guys? Yes.
Yes, sir.
So then how do we write? We put first the upper limit. So what would be that? Function is 1 by x.
1 raised to cube.
This is not power. Function is 1 by x. Fx is 1 by x. So 1 by 3, right?
3.
This is not 1 by x cube. This is not, right?
Yes, sir.
So 1 by 3 minus what is lower limit?
1. So 1 by
1 by 1.
1. So
Absolutely. So this is 1 by 3 minus 1. So this is
2/3
1 minus of 3. So
minus 2/3.
minus 2k by 3. So this is the work done, and we can see that this is negative, right? If k is positive, so the total work done is negative. Understood, everyone?
Yes, sir.
Yes, sir.
So this is work done by variable groups. You guys please note down from here, right? And the geometrical representation of this is, let's say you have a force, right? And let's say this is working on in the x direction and this is force which is fx. So when you calculate this integral, right? Let's say this is f integral of f dx from x1 to x2. So this is represented by this diagram, right? This is x1 and this is x2. So area under this graph, okay, this area. This is your fx, right? And this is the x. So this is the work done. Okay, area under this graph. So this is what we mean by integration. Understood?
Yes, sir.
So you
So,
guys, yeah, you guys please note it down and let's see if we can do this graphical one or not.
So, sir, in this question, x1 is 1 and x2 is 3.
Yes, absolutely right. Yeah. So in the limit we calculate. So this was the displacement from x1 to x. Yes, absolutely. Where is Akib? So Akib missed the class. And do you guys know the syllabus of Akib?
No, sir.
So in his school, the whole first book is coming. I don't know why. Why
For
they do?
70 marks,
Yes.
the whole book for 70 marks.
Yeah, in half yearly. Yeah, in half yearly. So in Akib's school, they are asking the whole first book, whole 7 chapters. So that is totally absurd and yeah. So why so much pressure? I don't understand. Because you guys just went from 10th standard to 11th, and that is totally different. So whatever you learned in your 10th standard and whatever you are learning in your 11th class, so that is totally different, right? Physics, chemistry, you are individually understanding all those subjects. So in your 10th class, you understood all those subjects in one class, that is science, social studies, and all those. And you are specifically learning those subjects in your 11th class. So this is a totally new thing in your 11th standard. And why so much chapter in one go? So that is, okay, yeah. Whenever you guys have noted it down, please tell me so that I can scroll down.
Done, sir.
So two chapters, four chapters are good, but whole seven chapters.
Done, sir.
Then, so, note down.
Done, sir.
Then, Ilham and Amna, what about you guys?
Done, sir.
Good.
Done, sir.
So now the other method would be that, let's say that you are given so graphical method of calculating what. Okay, so the time is up now. But you guys, let me ask this question. So I have given you velocity time graph, and this is the velocity time graph. So if you calculate the area under this curve, so what you will get? Do you guys remember? In velocity time graph, if you calculate the area under this curve,
Acceleration.
acceleration in velocity time graph, hmm, what is v into t? Yes, in the graphical representation, we derive something from this. In velocity time graph, we calculated the area and we defined
Displacement.
displacement, right? So area under velocity time graph gives displacement. Okay. So similarly, if we have a force, let's say force and displacement graph, right? Let me write it as x. So then let's say the force is varying like this, right? So if I calculate the area under this graph, then what it will give?
Work done.
1 ton, right? Good. So area under force and area under force and displacement graph gives you work. So we will talk about this in the next class, but yeah, I will start from here. So no need to note it down. I will start it again. So you guys please, yeah, you guys please log into your Learnivio account and see whether you have gotten the active test or not. Right. So